Okay, so to put it mildly, the last test did not go very well. And I'm shocked because you had access to all of the information 24/7. It's just a matter of whether or not you accessed it. So I'm going to now go over the information and then have you go to Edmodo to answer questions. I will tell you when to pause and when to answer certain questions. So let's get started. The first 7 questions are going to be on this first video. So I will play the video, pause it, and then tell you to go answer those questions. So let's see if it'll let me play the video.
That's what makes it positive. If you were to add electrons, it would become negative, and then you have what's known as an anion. Right? If you are looking at different elements written down, and you see pluses, or plus with a number, or minuses, and minuses with a number, these are atoms. So if it's just a plus, that's an understood 1 afterwards, so it's +1. If it's just a minus, it's a -1. Just in case you didn't know, this is an I for iodine, and this is an O for oxygen. It's not 1 and 0. These are the ions, these are the atoms.
Alright, so I'm going to pause it there because I started a little bit into the video, but as you can see from what's written on top, ions are atoms or groups of atoms with a positive or negative charge. Taking away electrons or losing electrons gives it a cation, becomes a cation, it's a positive charge. Adding electrons makes it a negative charge, which is known as an anion. Alright, so let's move on to the next page.
Okay, forming cations and anions, like I said before, cations lose electrons, anions gain electrons. And generally speaking, metals will be the ones that lose electrons to make cations, and nonmetals will gain electrons to form anions. Alright, let's move on. This is just a summary page. I'm not going to talk it over because this is all stuff that if you want to copy it down, feel free. That is all we've gone over so far in class. So I will do another video with average atomic mass after we go over Bohr model. Okay?
Okay, so I'm pausing it there. The first 7 questions should be able to figure this out, mainly because I have this part written down right here about electrons. So the first 7 questions, based on the video that I was talking about, plus this part right here, which we went over in class very extensively. Alright, so pause now and go to Edmodo, answer the first 7 questions. Okay, so now it's chemical bonds. I'm going to play this video for a little bit and skip ahead in places, but as you can see, here's bonding, and here we go.
Okay, now we are starting bonding. So to start off, we are going to talk about what a chemical bond is. A chemical bond is the force of attraction holding atoms together due to the transfer or sharing of valence electrons between them. And we talked about valence electrons and how atoms want to have 8. So in order to do that, they will react. Atoms will react in a way that will make them more stable. They will either gain, lose, or share electrons. Gaining or losing, that's what transfer is. And then once they've done so, they have combined chemically to make a new substance. Take a second, pause this, copy this stuff down. We will go over what these are in a few minutes. This is called Lewis structures. Okay, next up, diatomic elements. Some of you have asked me about this in the past because of, I think it was the alien periodic table it came up on. They're elements whose atoms, when found in nature, are always attached in pairs. So you're never going to see just one hydrogen atom or any of the others listed here. They're always going to be bound to each other. So that's why it says H2, O2, N2, F2, Cl2, I2, Br2. It's each one of these elements, they are found bound to each other. Important fact or important information that I don't have written down on any slide, this little number that is below. You're going to see it a lot more. Talk about it more when we go into writing chemical formulas. But right now, I want you to know that this is a subscript, S-U-B script, sub like submarine because it's below. All right, you'll be hearing me say that a couple times during this. All right, so what part of the atom is involved in bonding? Be specific. I want you to write this down in your notes. Do so right now. So in a full sentence, tell me which part of the atom is involved in bonding. Pause, write it down, and then come back. All right, moving on. Valence electrons, those are what are involved in bonding. This is all information that we've done already, but it's here if you want to copy it down or take a screenshot or whatever you'd like to do. I'm going to go on to the hints right now. So predicting group 1, and which are mostly alkali metals, has 1 valence electron. Group 2 has 2. Groups 3 through 12 can't be predicted. You need the oxidation number, which would be on a periodic table or is given to you by me. And groups 13 through 18, subtract 10 from the group number, and that gives you the number of valence electrons. Stuff we've talked about already. Okay, if you want to copy this, pause it. I'm moving on. The octet rule. All atoms want to have 8, the magic number, in their outer shells, except for hydrogen and helium. They only want 2 because they only have 1 shell, and 2 is the most that shell can hold. So what do you think happens if an atom does not have 8 electrons in its outer shell? I'm going to answer that. You don't have to answer it in your notes. An atom with less than 8 will most likely bond. We went over that just a couple slides ago, and we went over it before the test on periodic table. Okay, electron dot diagrams, also known as Lewis diagrams or Lewis structures. They're going to show the number of valence electrons an element has and how it can bond. That's what it's used for. So, if it has 1 valence electron, it has 1 dot. If it has 2, it has 2 dots. You know this based on either an oxidation number if it's a transition metal or what group it's in. So, the rules for electron dot diagrams. You start with 1 dot on top and then go, I'm sorry, not on top. That should be on the right. Sorry. I'll put it in right now. On the right and then go clockwise, as you can see here. So the first one goes at 1, 2, 3, 4, 5, 6, 7, 8. That's the way it goes, like it or not. Okay? So right now, your task is to create Lewis dot diagrams for the first 20 elements. Pause it on this page so you can refer back to this for the directions. Okay? So the first 20 elements, atomic numbers 1 through 20. You should know some of them by heart because your homework was to know the valence electrons for 7 elements. Okay?
So I just stopped that right there because what I want you guys to do now is go to Edmodo and you're going to answer, just let me make sure, the next, let me see, questions 8 through 18. Okay, based on the information that you just got, you should be able to answer 8 through 18. If you can't, the other information will be coming shortly. All right, so pause and then come back. Okay, now I'm going to show the video again on the three main types of bonds. Remember, covalent is then split up further into polar and multiple, but those are still part of covalent. So let's get started on that.
Ionic bonds. This bond is also known as the stealing or taking bond. An ionic bond is going to form because of the electrical attraction between anions and cations. So, when valence electrons get transferred, one will then be positive, the other will be negative, and that positive and negative opposites attract is what keeps them together. Sodium chloride, which is making up table salt, which is what makes up table salt, that stays together because of an ionic bond. It always occurs because of metal and a nonmetal or polyatomic ions. Polyatomic ions look like chemical compounds because they're made up of several atoms. The problem is it doesn't have an overall charge of 0. There's going to be a positive or a negative. I will go more into polyatomic ions in a little bit, but polyatomic ions are going to have ionic bonds. Okay? This is the sharing bonding. So the other one was stealing, this one's sharing. Electrons are shared between elements. Covalent bonding involves nonmetals only. So the electrons are going to, as it says here, spend time between the 2 nuclei. So this is 2 hydrogen atoms, and they are sharing their 2 nuclei. Usually they'll spend most of their time in the clouds between the 2 nuclei. So it's a little bit more positive here, okay? Protons and the shared electrons attract one another. The attraction is based on the covalent bond, as it says right here. Okay, covalent sharing. Don't worry about the charge of the atom. It's just sharing because they're going to share their electrons. That's how they get their full valence shells, and that's how they have a 0 charge. That is a bond between more than one metal. It's loosely held. Because it's loosely held, the valence electrons can wander among the different metal cations. Okay, so it looks like this. It's a wandering. So we had stealing for ionic, sharing for covalent and polar, or polar covalent, and metallic is wandering. The electrons wander and that's what keeps the things together because they're constantly wandering around. This wandering allows the metal to be conductive because the electrons can move through very easily, malleable, things move out of the way very easily, and ductile, things can be pulled very easily. Alright, so that's it on the different types of bonding. We're going to go.
Okay, so this is bringing you to the next section to to answer questions on. I'm just going to double check to see what those numbers are. Believe it is 1, 2, 3, 4, the next 4 questions. Hold on, I'll check and I'll be right back. Okay, you should be able to answer now questions 19 through 23, possibly even 24 if you were paying attention during ionic bonding. So go answer those now and come back. Okay, so now I'm bringing up the information on ionic bonds. This is binary ionic bonds to start with and chemical formulas. I'm only going to do maybe one example. I'm going to go through it quick and then move on to polyatomic and then covalent. Alright, so here we go.
Chemical formula. So to write a chemical formula, you need to know certain information. First off, what is a chemical formula? A chemical formula shows how many atoms of each element are in the compound. So CaCl2 is calcium and chlorine, and it is actually called calcium chloride as a compound. I'll get into that in a second. This formula tells me that I have 1 calcium, there's no subscript, so it's an understood 1, and 2 chlorine because of the subscript right next to it. Okay, this does not mean that I have 2 of this total atom. It means that I only have 2 of this, 2 of this total molecule. I only have 2 of this type of element. Alright, so let's go to a page that looks extremely overwhelming.
Okay, so the page right before, I'm just going to go back to that one, and I apologize for repeating it. I didn't want to, but it won't let me change it. So just go back to see this whole page. Alright, so here's some information. You could pause it on here to help you. This is some information about ionic compounds, and I'm going to quickly go on to something else. So let me pause this. These are some examples we did in class. I'm not going to actually play the video, but as it says here, the charges cancel each other out. Once you figured out what the charges are, there's no subscript, so you have NaCl. If the charges are different, cross the absolute value of the charge down to the other element. Absolute value means there's no sign, so you just take the number and cross that down. In this case, the 2 would go to the outside of the F, and the understood 1 would go to where the BA is. So the answer for this one would be BAF, and that's it. I'm sorry, BAF2. Okay, so pause again, because now you can answer questions about polyatomic ions. My mistake, I said you can answer about polyatomic ions. No, you can answer about regular ionic compounds. Okay, I'm not going to put the whole video up for polyatomic ion compounds because pretty much it's the same as regular ionic compounds. The charges have to cancel each other out. In this case, you have a polyatomic ion, which is made up of 2 or more elements with subscripts more than likely and a charge. So if you have a polyatomic ion, you have to put it in parentheses first with the oxidation number or the charge outside the parentheses, like what is shown right here or here. Okay, polyatomic ion phosphate, PO4 in parentheses with the -3 outside. And just like with the other ones, as it shows a little bit further on, and I say other ones, the ionic compounds, you're going to cross down the charges. So I see phosphate has a 3 charge, cross down the charges, and that's the way it goes, and that's how you get this answer right here. Next, going to naming ionic compounds, and here we are. First element, the metal, always stays the same. The second element, non-metal, ends in IDE. Okay, that is an answer to a question. Oxidation number is telling you the charge of the Roman numeral is telling you the oxidation number of the metal when it's a transition metal. Oxidation number is the charge. So check, you need your periodic table with you to check first if the element is a transition metal. So like this right here. Okay? Normally you would just want to write iron oxide, but if you check the periodic table, you'd see that iron is not in groups 1, 2, 13 through 18. It's actually in transition metals. And because it's a transition metal, you're going to have to write down that it is iron, in this case, iron 3. So iron, Roman numeral 3, oxide. Okay, so I'm pausing there. I'm going to probably get cut off, but this is where we're going to have to stop. For covalent bonds, just pull up the covalent bonding video. It's very straightforward. Okay, see ya.